All right, 7.2, verify trig identities. So we're jumping down all the way to number 34. Each expression simplifies to a constant, a single function, or a power of a function. Use the fundamental identities to simplify each expression. So some of this is going to be like very similar to what we were doing yesterday, and then it'll go into the next stuff where we are truly verifying that like one side equals the other side. So 34, cotangent of, they use alpha, but I'm going to use theta just because it doesn't matter, but anytime you see like they're doing that like for alpha, and sometimes they do this as beta, but you can change them to like x or theta or something like that if you would prefer. So cotangent of theta times sine of theta, and I want to reduce down. So how or what can I rewrite in terms of something else?
Okay, that'd be 1 over tangent theta.
Okay, so is that going to help me cancel something?
No.
No, so is there another way I can rewrite it maybe?
Oh, so sine. Oh yeah, cosine theta over sine theta.
Yep, cosine theta over sine theta. Because now that will allow me to cancel top and bottom and leave me with cosine theta. (38) Cosecant theta times secant of theta divided by cotangent of theta. So, can I rewrite any of this? Or what's another way I can write cosecant?
1 over sine theta.
1 over sine theta. How can I rewrite secant?
1 over cosine theta.
1 over cosine theta. And how can I rewrite cotangent? Maybe in terms of sine and cosine, since these top things are already in sine and cosine.
Cosine theta over sine theta.
Yep, cosine theta over sine theta. So now I've got basically fractions and fractions. So how do I normally deal with that when I've got the fraction on the bottom? When I divide by a fraction, what do I do? Keep, change, flip. So I'm going to have on the top, I'm just going to combine those as 1 over sine theta cosine theta, because that's the same thing that's written there. I've just simplified it into one thing. Times, flip this, sine theta over cosine theta. So now everything's being multiplied. So I can cancel the signs out here.
1 over cosine squared.
Yep, which is 1 over cosine squared theta. And what's another way I could rewrite that? Because I don't want it left that way, since it's 1 over. Like if you just had 1 over cosine, what would you tell me that's equal to? Secant, and this one is squared, so this is just going to be secant squared theta. This one's an interesting one. 44. 1 minus 1 over secant squared of x. All right, so how could I rewrite 1 over secant squared?
That'd just be
Yep, cosine squared, so this is going to become 1 minus cosine squared of x. Then 1 minus cosine squared of x would be equal to what? Sine squared, because when we have sine squared plus cosine squared is equal to 1, and I do sine squared is equal to 1 minus cosine squared, that gives me my answer. So just a manipulation of our Pythagorean identities again.
So we just treat the x like a theta?
Yeah. And the book uses alpha and beta and t and all those different things, but you can, if you want to make them all thetas just to be consistent, that's fine too. Not going to change anything. Just don't change them all within the problem. Don't be like, I'm going to do theta on this row and x on this row. Like, just keep, as long as you keep it consistent throughout the problem. When I put them on your like quiz and test, usually I'll use either all x or all theta, like typically, just because it's actually the easiest to type in just x. To type in theta is a little more work on my part, but it just depends on the day. All right, now we're getting into verifying the identity. So all what we just did is just like a little bit harder than what we did yesterday, but the same process. And that's really going to still be true for what we're about to do. But something that you need to know about verifying. So with verifying, only change the left side. Leave the right side alone. So to verify, I can only manipulate one side. And in the case of our book, it's going to be the left side all the way down. So when I set these problems up, I will actually draw an arrow all the way down on the right side so that I don't have the temptation to move things from left to right, because that's not verifying it. We're trying to make the left side look like the right side when we're all said and done. So 46. We've got tangent, again they use alpha, I'm going to use theta. Tangent theta over secant theta equals sine theta. So, doesn't need to be like obnoxiously long or anything, but I'm going to just draw an arrow there because basically that just blocks out that I can't touch the right side. Like I would have to write over top of my arrow to be able to do anything to that side. So that way I don't have the temptation to do anything with that one. So on the left side, I have tangent of theta over secant of theta. How can I rewrite those things to try to get to sine theta? So what's the way I can rewrite tangent of theta?
You said tangent theta.
Yes.
1 over sine theta over cosine theta.
Sine theta over cosine theta. And then how can I rewrite secant of theta?
1 over cosine theta.
1 over cosine theta. So now I'm dividing by a fraction, so what do I do? Keep change flip. So I'm going to have sine theta over cosine theta times cosine theta. Cosine thetas cancel. And so I get to the end result that sine of theta is what I'm left with on the left, which is equal to sine of theta that they gave me to start with on the right, and I have verified it. So basically, it's the same stuff we did yesterday. They're just telling you what they want the end result to be. So, not to be this way, but there's no reason to get these wrong, right? Because you know what the end result is supposed to be. But I'm also going to tell you that sometimes people decide that they're going to do some little work in the middle that makes no sense. And at the end, they're like, well, I know it's supposed to be equal to sine theta. If I write sine theta equals sine theta, she's just going to give me the points. I go back through and make sure that your steps make sense. Okay, so you can't just give me like barbecue sauce, in the middle and expect that I'm just going to give you all the points. Okay, so, but you can do these problems by basically ignoring that the right side even exists, solve them down like you would have the problems we did yesterday and then the first ones from today, and get the end result, and then just show that they were equal to each other too, if that helps you to think about it. Let's see, next one. 48. They really like alpha in these problems, but I'm just changing them all. Tangent squared theta plus 1 over secant of theta is equal to secant of theta. So I'm going to put my arrow here so I don't touch this side. So now I need to look at stuff on the left that I could potentially rewrite. On the top, I see a squared term and a 1, so I'm thinking maybe a Pythagorean identity. Is that one that we have?
Secant squared theta.
Yep, so that's equal to secant squared theta. So I've got secant squared theta over secant of theta. And I didn't rewrite the bottom one because the top's in terms of secant. I see that I'm trying to get a secant as the end result. And so now secant squared divided by secant is?
Secant.
Just secant. Yep, secant theta equals secant theta. And I verified it.
I feel like this is easier than what we did yesterday.
It kind of is if you're somebody that, if you know the end result, you know what you're trying to get to. Because you kind of know if you're done or not. Because that's what sometimes people don't go far enough on the ones like this because they don't know that they need to keep going.
Yeah.
So it's kind of like you have to keep going until you get there with those ones. But with these, you're like, well, I got to secant of theta. They clearly don't want me to do anything else because that's what they were trying to get. So, yeah, I do think these can be a little easier. Plus, once you get more familiar with all the identities and stuff, it makes it a lot easier too. So, let's see, 52. Sine squared theta plus tangent squared theta plus cosine squared theta equals secant squared theta. So with this one, I'm going to bring this down so I don't touch it. I see a lot of squared terms, and so when I see squared terms, what am I thinking about?
And the Pythagorean identities.
Yeah, Pythagorean identities. So is there any part of the left side that I have all the pieces to one of the identities? Obviously, other than what it's equal to.
No. Wait.
How about if I rewrite it like this?
Can you move secant over?
Nope, I have to leave this here. But if I rewrote this as sine squared theta plus cosine squared theta plus tangent squared theta, now do I have something that I can rewrite as one of my identities there?
Oh yeah. Sine squared theta plus cosine squared theta is equal to 1.
Yep, so this would be, I'm replacing sine squared plus cosine squared with 1. So I'm left with 1 plus tangent squared theta. And then what's 1 plus tangent squared theta?
Secant squared theta.
Secant squared theta. And look at that. That's what I was trying to get to. So this first step here, if you recognize that there's a sine squared and a cosine squared here, you could have skipped this intermediate step. But I wrote it so that we could see where the sine squared and the cosine squared, like having them together to rewrite that, is. Because everything that's being added, you can write it in whatever order, and it's going to give you the same thing no matter what. Let's see, 56. Secant to the fourth of x minus secant squared of x equals tangent to the fourth of x plus tangent squared of x. So this one's going to be kind of weird compared to the other ones that we've done. Because it.
Just add those together.
So I can't because they're different powers.
Oh yeah.
But what I can do is I have basically, both are secant terms, so I could kind of do this like factoring. So like if I had like x to the fourth minus x squared, and we take out an x squared, so we get x squared times x squared minus 1, I can kind of do it like that, okay, with the trig functions. So I'm going to take out a secant squared of x. So secant squared of x times secant squared of x minus 1. So now, is there a way that secant squared of x minus 1 can be rewritten?
Maybe, wouldn't it be tangent squared theta?
Yep. So tangent squared, and just because this problem, well, for me it's in x's. If you do use theta, that's fine. But so I've got secant squared x times tangent squared x. But I know I'm trying to get to everything in terms of tangent, so I think it might be wise for me to attempt to rewrite this secant squared using the Pythagorean identity in terms of tangent. So what is secant squared of x equal to?
Tangent squared theta plus 1.
So I'm going to rewrite that as tangent squared x plus 1 times tangent squared of x. Now what? So I'm not quite to where they want me to be yet.
So that'd be
Just multiply.
Yeah, just distribute, multiply. So I'm going to be distributing this tangent to both pieces here. So I've got tangent to the fourth of x plus tangent squared of x is equal to tangent to the fourth of x plus tangent squared of x, which is what they were trying to get me to do. Any questions on those? Feel okay about them at the moment. All right, I'm going to go ahead and give you a few to do, and then if we need to go over them tomorrow or something, like we can, obviously, because I want to make sure. And the other thing I'll say is sometimes these steps in the middle, like you may not have the exact same steps as someone else in the room. Because there's sometimes, like, all these ones have been pretty, like, definite of, like, this is the way you have to do it. But you may not have the exact same number of steps or, the same exact steps in order. As long as the steps make sense, that's what I'm looking for when I grade it. Like, here, if you had realized that, that when we were going to here, well, I need everything in terms of tangent, so I should probably go ahead and rewrite secant. I might not have even had this middle step. I might have just gone straight from here to here. kind of thing. So that's what I'm saying. Sometimes you might have more steps or less steps, depending. But as long as it makes sense of how you got from point A to point B, that's what I care about. So problems for you, 33, 37, 43, 45, 49, 51, and 55.